Hey, this is Zach from ZachMakesGames.com with a follow-up to my previous video on quad trees. I had a lot of fun putting that demo together, but of course I'm always itching to go one step further with a project if I can, and I thought it would be really fun, since I had minor interactive elements with that demo, to kind of turn it into a bit of a game of sorts. And I had this kind of idea in my mind of, well, what if I flew a helicopter over the forest and dumped water on trees to douse them and stop the forest fire? Thought that would be kind of fun. And I had a demo for a class, my OpenGL class specifically, where I flew a little helicopter around a city. And I thought, well, that wouldn't be really hard to adapt into an interactive demo. I always wanted to be able to fly that helicopter around the city rather than have it be just a static scene. So I thought, hey, let's give it a shot. It gives me a chance to work with quad trees a little bit more, and it also would get me back into working with 3D graphics a bit, because I haven't actually worked with a raw 3D graphics application in a long time. It's been a while. It's been basically since I took classes. I've tinkered with things here and there, but I haven't really put together a solid demo since. So I thought, well, hey, screw it. Let's try it. Let's give it a shot. What's the worst that could happen? I could end up with nothing and be out nothing, or I could have a cool little demo. So here it is. I put it together, and it works great. This is being rendered with Vulkan. I'm using instance rendering for the trees to make the render time a lot faster, and that was something that I knew right off the bat I would have to tackle, is getting instance rendering working the way I wanted to. And I've also got the quad tree underlaid, just like the other demo, although in this case it's underlaid rather than overlaid, and I have a little helicopter that's flying around the scene that I am in fact controlling. So I can go forwards and backwards, I can turn left and right, I can go up and down, and I can just fly around this forest in a little helicopter, which is really awesome, honestly. This is a pretty fun little demo that didn't take me a whole lot of time to put together. So I had a few challenges with this demo, though. The first one was instancing. I knew that if I couldn't get instancing working right, that this would be dead in the water. It would just take too long to render, and my quad trees would just totally overrun the time it took. Even if they worked efficiently, if my render time was too high, there wouldn't be any room for extra things like searching a quad tree. So I did some digging and realized that the instance rendering example that I had from school was cheating, really. We weren't actually doing any sort of significant instance rendering. We were passing the mesh one time and the number of instances, but then we were just simply using the instance ID and the shader to position the object within a grid. That was it. We were just finding the coordinates in a grid for the object rather than specifically placing and orienting objects. So I needed to add extra data to each instance so that they would go where I wanted them to go and do things like be the right color too, because the trees were changing colors. They're distributed randomly across this forest. There's extra bits that I needed to have. Turns out with Vulkan, it's pretty simple. You just have to create another buffer and bind it with the per instance input rate rather than per vertex, and then you just bind that buffer when you call the draw call, and voila, it works. As long as you hook it up in the shaders, of course. The shader has to add some things to like position it correctly based on its instance data and stuff like that, but that was easy. That was the easy part. So I got that working pretty well, and then I had to implement the quad tree. And going from C# to C++, because Vulkan is a C++ only API, that posed a few headaches as well. The differences in memory management made it a bit of a challenge to rewrite in C++. I couldn't quite just copy and paste. There's a few things that I could copy and paste because they were things like simple math that worked out okay, but I did have to do some tinkering, and it gave me a little bit more of a perspective on some of the challenges that something like a quad tree would face in C++. So that was cool. But once I got that all working, it was pretty easy to do things like draw the grid, draw the trees, fly the helicopter around. I had done interactive projects before, so it was easy to set up the input And the camera movement is pretty simple. I didn't even have to really implement a true camera controller. It literally just follows the helicopter. It's pretty simple. And then the simulation is very similar to the 2D simulation as well, except this one isn't hand cranked. So I'm going to stop flying around for a little bit and blabbering on about the cool tech that I used for this demo and actually show how this demo works. Very similarly, I can pick a random tree to spontaneously ignite, and there it is right there. So let's go over and look at this tree. I have the simulation paused right now so that this doesn't blow out of proportion while I'm trying to show off how things work. I can pause it and I can unpause it. So I'm going to unpause it for a second, and there it goes. It spreads again. It spreads slowly over time to give you a chance to interact with it and kind of play the little mini game thing that we've got going on. So I, as a forest firefighter, am flying a nice blue helicopter over this forest, and every tree that I fly over, basically, I'm going to douse with water. I don't have the special effects for it here. Maybe I'll do like a particle effect later. I think that'd be cool, but this is simple. I wanted to keep it simple. So I can fly over, and we'll see that the trees turn green again. This is just like clicking on the screen in the 2D demo. It's the same thing that's happening. I'm doing a search through the quad tree to find all the trees within a given radius of the helicopter. And if I fly down to the grid, what we'll actually see is that the radius of the blades on the helicopter, the reason that they're so big is because they actually represent the radius of the search that I'm going to do. So I thought that was kind of a fun little visualization. And of course, as you fly up, since they follow you, obviously it's not going to encompass all the trees that fall within it given this view. But if you were to project the circle straight down, that's the radius that you would extinguish the trees. So I can do the same thing in the 2D demo. I can set multiple trees on fire, and there's a good bit of them right there. I'm going to unpause this and just let this simulation run for a second, and we'll see that it spreads exactly like the other simulation did. I can't tweak the spread radius in this one on the fly. That is something that I probably could easily do with keyboard inputs, but it's something that I didn't really think about as being necessary for a simple little game like this. But it's something that, could be implemented as an addition or something like that. But I can actually go ahead and fly over and try to contain this fire. I'm going to tell you right now, there's no way. It's just not going to happen. The whole forest is on fire at this point. But I can reset the simulation if I want to. So I can go ahead and hit the O key on my keyboard and reset the simulation. I'm going to set one tree on fire, and let's go see if we can contain the spread of the fire. It's already gotten pretty big. It doesn't spread super fast, but it's amazing how fast it will really go when you're on the other side of the forest. So I'm just going to fly around in circles and see if I can stop the spread. And it looks like pretty quickly I stopped the spread, and that's due to the way that it actually handles the spreading under the hood. A tree is only capable of starting a new fire for 2 frame updates after it had caught on fire itself. And the reason for this is that if we let a fire spread, the trees that are in the middle of the fire, so these trees right here, there's nothing for them to set on fire. It makes sense to not search these trees because we know that there's no way that they could spread to something because the something will already be on fire after even just one update. It doesn't take more than one update for a tree to have spread to its neighbors and then basically become unviable for spreading. So what this does is it saves us a lot of time in searching, and it saves us a lot of frame time as well because that search time equates to loss of frame time. But we do it twice so that it adds a little bit more of a challenge. You can't just fly over it once and be done with it. It will keep spreading a second time, so it does actually add some challenge to it. There's some things that I could do, like when I douse a tree, I could search for all the trees that are nearby within the radius, maybe just a little bit beyond the radius. I could search for all the trees that are nearby to all the other trees that I just doused, and if they're on fire, I could reset that spread timer. That's what happens in the 2D demo. But for something like this, I thought let's just keep it simple. Let's let it die out and kind of makes sense because a tree, once it's on fire, will get to the point where the fire is no longer raging in a sense. It kind of smolders for a while. So it kind of makes it a little bit easier on the player if you want to actually try and play this like a game. I can do some other kind of fun things with this demo too, like I can turn the lighting off so that we just get the pure colors, so you see that the trees are just all glowing green now. This is kind of interesting because it makes it a little easier to spot a singular tree or a small clump of trees, so that's kind of fun. I can turn that on and off. There's a few other things that we did in our initial instancing demo that still live in this demo as well, keyboard inputs, but for the most part none of them work because I ripped all the shaders out and put in new shaders to handle everything. So this project was a lot of fun. I really love working in 3D, and for some reason I just really love Vulkan. Vulkan is such a cool framework, and it just feels powerful to me. Working at such a low level and having the framework not hold your hand makes it feel like it's more powerful. I don't know why. I really like working with Vulkan, and it's pretty awesome to be able to see 3,000 trees rendered at 60 FPS with no problems. And these trees, sure, they're not very complicated. I made them in Blender in about 2 minutes, but it's pretty awesome to see the power of instance rendering coupled with a really awesome search technique or spatially partitioning technique such as a quad tree. It's cool to see the technology married together, and it really shows the point. It proves the point that we have to be vigilant to more efficient methods when we're doing things like real-time games. So I hope you've enjoyed this one. I won't be posting the code for this one because it did derive from a class project. So sorry, this one's not going to get posted on GitHub. There's a little bit of a snippet about this in the write-up on my webpage as well, but most of the technically interesting details I went over in this video, which will also be linked on the webpage. So I hope you've enjoyed, and I hope to catch you next time. See you later.